This is Andrew Jones at Climate Interactive, working with MIT Sloan's Sustainability Initiative, solving an En-ROADS puzzle. We've got a puzzle, folks. Can a carbon price deliver on 2 degrees? What does it take? What are the nuances to the answer to that question? And the puzzle comes from addressing this idea that's out there in the world. We've heard it said that a global $50 to $100 carbon price, that's in CO2, by 2030, with continued increase, would deliver 2100 temperature well below 2 degrees. So is that true, and where did it first come from? Came from, we think, the UN report, the report of High-Level Commission on Carbon Prices, Stiglitz and Stern, May 2017, and some figures. I'm not going to get into exactly the figure, but this is one of the important ones. Notice there are 5 integrated assessment models. GCAM, Image, Remind. These are the models. These are the shared socioeconomic pathways, SSP 1, 2, and 5, that they looked at, and different carbon prices. Another figure, figure 2, had trajectories for 4 different scenario types of SSPs, these different integrated assessment models, what the price is at different times to deliver well below 2 degrees. So these studies said that, and so we come to believe this statement. Therefore, my team with Climate Interactive, using our simulator En-ROADS, we want to say, okay, great, let's simulate a carbon price here in En-ROADS and see that 2 degrees. And it should just show up as 2 degrees because En-ROADS is consistent with the models behind that report, those exact integrated assessment models for those SSP scenarios. In fact, here's one variable. We actually compare against 30 variables, but this is greenhouse gas net emissions, 2000 to 2100. The red lines are the integrated assessment models for their baseline under SSP2, and then a lower radiator forcing level in orange and yellow and purple and green. And we tested our model at En-ROADS by comparing it. And so you can see that we're in the envelope, which just builds our confidence, yes, that we're consistent. And then we test it against other SSPs. This is the sustainability scenario, SSP1, and we can see how we're in the envelope of the other models, consistent with the integrated assessment models, and consistent with SSP3 and SSP4. And of course, our purpose is to make this kind of analysis accessible in real time to decision makers. That's why we complement these excellent integrated assessment models that are so great at capturing global dynamics. And by the way, if you want to learn more about all this testing, full training video number 8 on this website will get you there. So, all right, we're consistent. Therefore, a carbon price should get us 2 degrees. So I'm going to replicate a carbon price, and I'm choosing one kind of like Citizen Climate Lobby's proposal for a carbon price. And what they're saying is, let's go with $15 a ton, and let's do it immediately in 2020. First year, boom, 15 in 1 year, and then it's going to grow all the way up to the maximum we allow in En-ROADS here, which is 850. It's going to start doing that in 2021, and it's going to achieve that. The math that they came up with was 58 years, not 10 years. So there it is, carbon price growing steadily, similar to what was tested in those integrated assessment models. Look up here, we can see it changes the energy mix, but what? 2.6 degrees, not 2 degrees. That's the puzzle. What happened? Why 2.6 degrees and not 2 degrees? What is going on? That led us to dig around a bit more and say, well, let's look and see, make sure we did it right. These are the curves for carbon taxes for YASA, PNNL, PBL, and then Climate Interactive's En-ROADS model, and actually ours is on top of another one of theirs. You can't see it underneath the blue line. So when we input their carbon price, we can see the result of the integrated assessment models under the business as usual, the baseline up here, our line is in black. The other integrated assessment models for that scenario, radiated forcing of 2.6, and that carbon price is down here. This is part of the scenario that delivers temperature below 2 degrees. And look at the curve there. See that blue line rises to the 2020s and then it falls. And that's exactly the curve that you see here in En-ROADS in the version that's online for net CO2 emissions. So wait, the emissions of carbon dioxide are doing the same thing. Now note, this is emissions from energy. So we have the same curve for energy. So it's not that there's a different impact. We have the same impact of a carbon price on emissions. In fact, we studied it a second way. Just came up with some of our colleagues this idea of cumulative carbon price and the sensitivity of that cumulative carbon price the emission sensitivity to cumulative carbon price. That is CO2 price cumulatively up till, say, 2060, divided by how many gigatons of CO2 were avoided in 2060. It's a kind of a funny measure, but it gets you a sense of how much bang for your buck. Did that model reduce emissions a lot for every dollar of carbon price that was spent between 2020 and 2060? The black line is the average. The other results are these other colored lines for the integrated assessment models. The red one is Climate Interactive's En-ROADS. The main point here is we're not an outlier. Climate Interactive's model is consistent with the other measures for how much of a carbon price it takes to reduce emissions. So you'd think we would have 2 degrees as well. Well, we went back to that report, and here's the report, and we were looking at it, and then we noticed number 22 footnote in the fine print. And I blew it up so we can read it really well. And then next, there's the fine print footnote number 22. In the models used to make these estimations, these, quote, carbon prices are applied to all anthropogenic greenhouse gas emissions measured in CO2, E. Well, wait, that is methane from landfills, from wastewater, from oil and gas, agriculture. That is also nitrous oxide, that is F gases, HFCs, SF6, in all these other sectors, industry, agriculture, elsewhere, outside of the energy sectors, land use, forestry, etc. So it's really not a carbon price that they're testing. It's a comprehensive, global, all-sectoral greenhouse gas price that they're actually testing when they come up with these results. So they're not talking about a carbon price here. They're talking about a greenhouse gas price. So that really led us to see, well, how much of an impact did it have? And we looked at the data that they all publish and see, well, what happened with land use change in forestry? This one's really messy, I'm sorry, but our business as usual is up here. The lower emissions show the effect of less deforestation and actually growing trees, the gap between these two. But also significant changes on methane from those sectors that I mentioned of landfills and wastewater, agriculture, industry, oil and gas, where the business as usuals are up here. They assumed that that price would affect methane emissions because it's basically a methane price as well as a carbon price, reducing emissions down here to this lower level, significant cut in methane, but also driving carbon dioxide removal, a huge amount, over 10 to 25, above 25 gigatons CO2 per year late in the century. This is a huge amount of a combination. It had to be BECCS, bioenergy carbon capture and storage, direct air capture, mineralization, biochar, ag soil carbon, some combination of those things. So we see now emissions from energy, but also land use change, other gases like methane and nitrous oxide, but also carbon dioxide removal. So let's see if that's what's going on, because when we change the emissions related to energy, and one note, we actually got more than that out of the carbon price. I just want to note, if you look under here, This is emissions of non-CO2 greenhouse gas emissions, including methane. The black line is the business as usual. The blue line is this new run. Why is it lower when all we've done is a carbon price on energy? Well, this is cutting the emissions that come from oil and gas. So we're getting a second benefit that gives you even more of a benefit from the carbon price. It's affecting just coal, oil, and gas, but it is helping here with methane reduction as well. So here we are at 2.6. If our hypothesis is right from that footnote, then, well, if we cut deforestation emissions, another 0.1 lower. If we grow a lot of trees, they had afforestation, they assumed in the integrated assessment models. If they cut methane and other, we're down there at 2 degrees. And then if we get about 10 gigatons a year, and I want to make sure it's about 10, I'm going to go click here, CO2 removal of 5 different types, getting you, and afforestation, getting about 10 gigatons a year of removals. Actually, that's on top of the afforestation. There's a little bit more. That gets about 1.8, which is below 2 degrees, which is what the radiative foresting of 2.6 delivers in those models. So these are the additions to a carbon price that would need to get changed in order to replicate that finding in the UN report that said that a carbon price could get well below 2 degrees. So looking back at this statement, we can conclude that here's this statement: 5 to 100 by 2030 with continued increase would deliver 2100 temperature below 2 degrees if the price continues to grow, which we knew, but also it's actually a comprehensive greenhouse gas price. Or if we could think of it, if a carbon price could be expanded to cover 3 big areas. Forestry, land use change in forestry emissions, afforestation, reforestation is one. The second are methane, N2O, F-gases in agriculture, in wastewater, landfills, industry, oil and gas, and it could be expanded to cover carbon dioxide removal at a very large scale, possibly some combination of these 5 different areas. So that's the resolution that we have so far of our mystery. If you have any insights into it and you think it's actually a different thing, or you're part of a modeling team in integrated assessment models, please let us know if something else is going on to resolve this. Send me an email, find me on Twitter. We'd love to hear more from you. But overall, we really hope that these insights can help drive a carbon price to be passed around the world, because it's such a powerful way to help contribute to keeping temperature well below 2 degrees. Bye-bye.